solved in the last class. So this is a fixed beam with eccentricity loading of intensity 100 kilonewtons. Now we will solve, or we can draw the SFT BMD diagram by using moment area method. If we want to apply the moment area method, we will divide the diagram into two parts, which having the only given loading, second one having the only support moments. In both the cases, we will draw the bending moment diagram and we can calculate its centroidal location from the any one of the fixed point, that is either A or B. So in the last class, so these are the required equations. So this is in the last class we can complete it. So first I will consider part 1, that means which consists of only 100 kilonewtons. The maximum ordinate is WAB by L, that is 112.5. If you have any confused, or if it is 2-point load, then we will go to the standard procedure, that is sigma Fi. At point C, I calculate from the left side, RA into 4.5, RB into 1.5. The both sides we can get the same value. Calculate in equation A1 plus A2. A1 represents the area of the free bending moment diagram. So it is unsymmetrical triangle. A1 consists of AX plus AY. AX equal to half into, so that represents a green color, 4.5 into its ordinate 112.5 by EI. Coming to the AY, that is orange color, half into 1.5 into 112.5. First we calculate A1, that is AX plus AY, free bending moment diagram area. Next we can calculate X1 and X2. So that represent X1. We can calculate orange triangle diagram, its centroidal location with reference to from point B. Second diagram, orange diagram, its centroidal location from point B. All of you see for the orange shape. So that is 2/3 of the 1.5. That is from the apex. If we go to the green triangle, first I will identify it's for green triangle, it's 0.5. The second diagram, its distance from apex is 2/3, from the base is 1/3. Now we calculate it x bar is, sorry, AX equal to from point B, that is 1.5 plus 1/3 of the 4.5. Now if we calculate XAX equal to 1.5 plus 1/3 of the 4.5 XAY, so that is the orange shape, 2/3 of the 1.5, so that is 1. Any doubts in this calculation? My last class is complete అయిందా అవ్వలేదా? ఇక్కడ ఎవరికైనా డౌట్స్ ఏమైనా ఉన్నాయా? So how we can calculate? So this diagram will be obtained from the given loading. మనకి మనం assume చేసుకోవడానికి మనకి రాదమ్మా. ఉన్న లోడింగ్ బట్టి మనం బెండింగ్ మూమెంట్ డయాగ్రామ్ చేస్తే ఈ షేప్ వస్తుంది. Based on the shape, either it is 1 part or 2 parts or 3 parts. So మనకి విజిబిలిటీలో క్లియర్ గా అర్థం అవుతుంది. 2 parts ఉన్నాయా, 3 parts ఉన్నాయా. So next, either any one of the point you can calculate, either A or B. So second one. Now consider the effect of end moments only. Now I request all the members, second portion. That second portion we will eliminate that given loading. So here A2. ఇది కూడా అయిపోయిందమ్మా? Okay. There is a small confusion. Okay, నమ్మ. ఒకసారి డయాగ్రామ్ ఒకసారి చూడండి. Fixed end bending moment diagram where MA is constant throughout the member. So MB we think may be more. MB ఎక్కువ ఉంటుంది అనుకుంటున్నాం. అది క్యాలిక్యులేట్ చేసిన తర్వాత మనకి ఎక్కువ ఉంటుందో that we can get that from the final value. Here triangle, one is the rectangle, bottom one is the area AP into AQ. AP, so that is L into B. MA by EA into length side. Now it's clear. This the voice.
Sir,
Clear now?
మీ వాయిస్ బ్రేక్ అవుతుంది.
no sir, break అవుతుంది sir.
Okay, okay. Wait. Now, ఇప్పుడు ఎలా ఉందమ్మా?
Okay sir.
Okay, right. So if you see, there are two diagrams. One is rectangular, one is triangle. For rectangular, yellow color. So that is L into B. MA by 6. ప్రతి ప్రాబ్లం కి ఫిక్స్డ్ ఎండ్ మూమెంట్స్ కి ఇదే డయాగ్రామ్ రిపీట్ అవుతుందమ్మా. వేరియింగ్ పారామీటర్ ఏంటంటే లెంత్ ఆఫ్ ది స్పాన్. రిమైనింగ్ ఆల్ ఆర్ సేమ్. KP MA by EA into 6 for AQ, half into L into, all of you observe MB. So that we can calculate. ఒక్క నిమిషం ఇక్కడ చూడమ్మా. So the total is one side is MA, other side is MB. But we required only the orange portion. That means MB minus MA. For the triangular portion, the ordinate height is MB minus MA. So here we can get AP, AQ. And again we can calculate X2. So I think ikkada varaku complete ayindamma. Hello?
Yes sir.
Yes, sir.
Now we can calculate X bar distance. Same diagram. If you indicate XAP, XPQ, both are measured from the point B. In case of the simply supported, we can measure from the point B. In case of these fixed end moments, we can measure the point B. So now all of you calculate X2. So that is the distance of the centroidal location of the free bending moment diagrams. My notation is XAP. So AP is the area of that portion. I can call it as XAP. It's very simple. It is rectangle 6 by 2. If you take the upper portion, right angle. So from the base, 1/3 of the 6. The same formula is applicable to the all the cases. The only varying parameter is the length of the member. Sometimes they may be give 8 meters, 10 meters, 7 meters. XAP, my notation. If you follow any one of your convenient notation, XAQ, top portion, centroidal location from point B. XAP, if you observe that yellow color rectangle, so that is 6. Its distance is 6 by 2. Next, triangle portion, XAQ, so that is from the base 1/3 of the 6. So now it is for the one portion that is 3, one portion that is 2. Any doubts in the second diagram, its areas and its centroidal location? So now, if you properly understand, now the complete problem is in your hand. Can I go to the next slide?
Yes
Yes,
sir.
Right, thank you. Now, from condition 1, A1 plus A2 equal to 0. First I will take one condition. A1 plus A2. So A1 we can divide it into AX plus AY. From the next problem onwards, directly you can write that numerical values. So from the beginning, I have A1 is divided into AX plus AY. A2 is divided into two parts, AP plus AQ. So మీకు ఆల్రెడీ పైన వాల్యూస్ ఉంటుందమ్మా, డైరెక్ట్ గా మీరు సబ్స్టిట్యూట్ చేయొచ్చు. So for PPT, again I will indicate AX. There is no need to indicate again AX. First you will write from condition 1, A1 plus A2. What is that? A1 plus A2 represents the slope end at the fixed end equal to 0. So AX 253.12 by EI, AY 84.37 EI, and AP 6 MA by EI, AQ 3 MB minus 3 MA by EI. So now you will substitute all the values in condition 1. So the A1 253.12 by EI plus 84.37 by EI, all of you observe. So first one is the simply supported, that sign convention is positive. Second one is the negative sign conversion. So that is for the fixed end moments. Equation A1 plus A2. First one is the plus, second one is the negative. Carefully observe that sign convention. A1 plus A2. So that second portion we have assumed as the negative values. So that is the, by considering the fixed end moments only. The first portion AP is minus 6 MA plus EI plus 3 MB minus 3 MA. Now 253 plus 84, 337.49 minus 6 MA, minus 6 MA plus 3 MA. So that is 3 MA. Next one is the plus 3 MB. Plus into minus 3 MB by EI. So again, if we can divide it, that I will change the sign convention. Plus 3 MA plus 3 MB minus 337.49. Now divided by the equation by 3. MA plus MB minus 112.49. So this is equation 1. So while writing the sign conversion, second portion is the negative portion. So can anyone confirm either this equation is right or wrong?
Correct.
With sign convention, proper sign convention. So now you take second condition. Second condition. What is the second condition? A1 x1 plus A2 x2. Those who are completed condition 1, go to the second condition. If anyone having the no calci, now you can directly take the values. At least you are in a position to write down the equations. Condition 2. ఈ కండిషన్ కంప్లీట్ అయిన డైరెక్ట్ సెకండ్ కండిషన్ లోకి వెళ్ళి ఆ వాల్యూస్ అన్నిటిని సబ్స్టిట్యూట్ చేయండి అమ్మా. యూ విల్ గెట్ ది అనదర్ ఈక్వేషన్. సో కండిషన్ 2, A1x ప్లస్ this one is the second condition, A1x1 plus A2x2. A1x1 represents the simply supported bending moment diagrams that we can get the two triangles orange and green. X1 represents the centroidal location from the point B. A2 represents the area of the fixed end moments. X2 represents the its centroidal location from the point B. Second condition, A1 x1 plus A2 x2. Now this is my second equation, A1 x1. So I will write in detail AX XAX plus AY, area of the second portion, XAY, plus AP XAP plus AQ XAQ. In equation we have the plus. While substituting the values, we will put for the second portion as the negative value. AX is known value 253.12, XAX already we can calculate 3, AY 84.37, XAY 1, AP that is the by considering the fixed end moments 6 MA by EI, XAP 3 that is 6 by 2. Second one, 3 MB minus 3 MA by EI, XAQ equal to 2. Now we will substitute all values in the above equation. The first one is the AX 253.12 into 3 plus AY 84.37 into XAY 1 plus, all of you observe, I will put same plus. Next two portions having the minus. The first one is the minus 6 MA by EI, centroidal location 3, minus 3 MB minus 3 MA into 2. So if we multiply 253 into 3, 759.36. So 84.37 into 1. So that is 84.37. Now you see for the second, plus into minus 6 into 3, 18 MA by EI. Next one is the 3 into 2. So that is minus 6 MB minus into minus plus 6 MA by EI. If we add 759.36 plus 84.36, so that is I got 84.37. So minus 8 MA plus 6 MA. So minus 18 plus 6, that is minus 12 minus 6 MB. So now again I will modify the equation. 12 MA plus 16 MB minus 84.37. So if you divided that equation by 6, we will get 2 MA plus 6 by 6, that is 1 MB. 843.37 divided by 6, 140.56 by EI. So this is equation 2. While writing the second equation, you will properly indicate that negative sign convention. So AP is the negative, AQ is the negative. So this is my second equation. So those who are get the correct value, now you have the two equations, two unknowns. You will solve MA, MB. So like in case of continuous beam, we can get that support moments. From that we can calculate support reactions. This is for the condition 2. Can anyone confirm, is it right or wrong?
Correct, sir.
I request all the members.
Correct,
Next
sir.
would, okay, next from equation 1 and 2. Now you can solve. Now you have in your hand two equations, two unknowns. Any one of the method, by calci or by standard method, you can get MA, MB. So that MA represents fixed end moments, MB represents fixed end moments. Those who are completed condition 2, try to understand properly what is its area, what is its centroidal location, where we can give the positive, where we can give the negative. If you have any doubts in the beginning problem, please tell me. Don't put the same values, copy paste. While going to the Maclaurin method, that is too laborious method. Compared to other method, this one is the easy method. Even though it is lengthy, it will be easy step-by-step procedure. So now, so I will give the my values. So this is from equation 1 and equation 2. I got MA 28.07. Now in this case, we will cancel EI. Now after getting the MA, you will substitute in equation 1 or 2. I will substitute in equation 1. I will get MB 84.42. So now this MA, MB represents the fixed end moments. Two equations, two unknowns. Can anyone get same values or any other values?
Same, sir.
So both values are correct. MA, MB. Thank you. MA 28, MB 84.42. అందరూ ఈ స్టెప్ కంప్లీట్ అయిందా? All of you? మా ఇంకా ఎవరైనా పెండింగ్ ఉన్నారా? Can I go to the next slide?
Yes, sir. Completed, sir.
Okay, right.
Yes, sir.
Now, right, for these moments, get support reactions. The previous one I took, it is upward side. Next, support reactions for due to the fixed end, next side heading them. Support reactions by considering only support moments next to side heading. After calculating support moments, support reactions by considering the support moments. So RA plus RB, so that is RA2 plus RB2 equal to 0. So that is no additional load. Now RB equal to minus RA. So in previous all problems, all the cases, we will get RA plus RB equal to some value. But here there is no RA plus RB. So RB equal to minus RA. Now you take sigma MA. So RB2 into 6 plus 28.07 minus 84.42. There is no additional load. So now I will get RB equal to 9.39, RA equal to minus 9.39. So that's why I will indicate RA2 is the downward side, or otherwise you will kept upward side and that value you will indicate minus 9.39. మా కన్ఫ్యూజ్ అవ్వదు, RA వాల్యూ నాకు నెగిటివ్ వచ్చింది. So as per the upward side is positive, downward side negative. I will indicate downward. లేదు సార్ కన్ఫ్యూజ్ అవుతున్నామంటారా? Okay, you will put arrow symbol upward side. At that value you will write minus 9.39. Any is the so any one of the method is the we can follow. So these are the support reactions developed due to the only support moments. RA2 plus RB2 equal to 0. There is no additional load. So in general, by the standard procedure, we can assume so external load equal to 28.07 plus 84.42. That's not correct. The equation itself, sigma Fy, that is upward forces equal to the downward forces. Here upward is RA2 plus RB2. There is no downward force. So that will the only moment. Sigma MA equal to 0. So that RB2, by mistake RB and Padindamakada, RB2 into 6 plus 28.07 minus 84.42, RB equal to 9.32, RA equal to minus 9.39. So you will indicate, if you indicate upward side, put minus, or if you indicate downward, there is no need to indicate that sign convention. So any doubts in the support reactions? Still now we don't calculate final support reaction. So these are belongs to the only support moments, support reactions. Don't confuse RA plus RB equal to 0, not 28 and 84. Those are moments in the equation sigma Fy. Upward side forces equal to the downward side forces. My complete అయినా
Yes, sir.
Right? I request all the members hold for 1 minute. I request all the members. Now I will go to the previous standard diagrams. I request all the members don't write anything. Now if you see the diagram, diagram 1 represents the given diagram. Diagram 2 represents the, so in the diagram 2 we have the support moments. All of you clearly observe in the second diagram we have the support moments given loading. That second diagram is divided into two parts, that is diagram 3, that means support reactions having the given loading. Diagram 4 represents the support moments in RA-RB. If we want to get the final support reactions, we will add diagram 3 and diagram 4. నాకు ఫస్ట్ డయాగ్రామ్ లో సపోర్ట్ రియాక్షన్స్ కావాలి అంటే I will add diagram 3 support reactions, diagram 4 support reactions. Diagram 4 support reactions, just now we can calculate. Diagram 2 support reactions, we can calculate here. So these are the support reactions. Here we can call it as RA1 plus RB belong to the given loading. So this RA1 is 25, RB1 is 75. Now coming to the second one is, these are the support reactions. RA2 9.39, RB2 9.39. If we cannot RA1 plus RA2, that gives the final support reaction at point A. RB1 plus RB2, that gives the final support reaction at point B. మా అర్థమవుతుంది అందరికీ? నాకు ఫైనల్ సపోర్ట్ రియాక్షన్ కావాలంటే we will add RA1 plus RB2. Why? Because our diagram is divided into two parts. నాకు ఇనిషియల్ డయాగ్రామ్ కావాలంటే సెకండ్ పోర్షన్ లో థర్డ్ పోర్షన్ లో ఫోర్త్ పోర్షన్ లో ఉన్న రెండు వాల్యూస్ ని యాడ్ చేస్తే I will get the initial diagram. So then what about the support reaction at A? RA is 25, RA1 is 25, RA2 is 9.39. Clearly observe, one value is upward, one value is negative, that is plus 25 minus 9.39. We will get the one value. Then what about the RB? RB1 plus RB2. What is that RB1? Anyone? RB1 value entamma? 75. RB2 is 9.39. So 75 plus 9, nearly we can get 84. So now if we have the support, now you will see. So these are the support reactions for the given problem. Now I request all the members. The bottom diagram 3 represents the final support reactions. And you have the next side heading, final support reactions for the fixed beam. Previously support reactions for the only fixed ends. Now we will calculate final support reactions for the fixed beam. మీకు 1 or 2 ప్రాబ్లమ్స్ సాల్వ్ అయ్యాక డైరెక్ట్ గా మన వాల్యూస్ నోట్ చేయొచ్చు. సో ఫస్ట్ I will take one diagram. So that is RA1, RB1. So these values obtained from the 100 kilonewtons. Second diagram represents RA2 9.37, RB2 9.39. If you take at point A plus 25, so that is RA2 minus downward side 9.39. So 25 minus 9, that is 15.61. Next one is at point B, RB1 plus RB2. Both are in the upward direction. The green and blue color in the upward direction. 75 plus 9.34. So that is 8.39. First, take one diagram, indicate RA1, RB1. Next, take second diagram, RA2, RB2, indicate the values. Now, at A support reaction, RA equal to RA1 plus RA2, 25 minus 9.39. So that is 15.61 is the final support reaction related to the fixed beam. At B, the support reaction equal to At B, the support reaction equal to RB1 plus RB2. RB1 is 75, RB2 is 9.39. So final RB equal to 84.39. So at the bottom diagram, we have the support moment, support reactions. Now we will calculate bending moment at various points, shear force at various points. Then only we can draw the bending moment diagram. If we can draw the support reactions 9.39, 9.39, that gives the wrong information. We will draw the SFD BMD diagram for the fixed beam. The fixed beam can be obtained combination of the simply supported plus considering the fixed end moments. So any doubts in this diagram, please ask me. Initially, given diagram is divided into two parts. In each case, we will calculate support reactions and we can add that support reactions. We will get the final diagram. ఉన్న డయాగ్రామ్ ని రెండు పార్ట్స్ గా డివైడ్ చేస్తున్నాం, వాల్యూస్ క్యాలిక్యులేట్ చేస్తున్నాం, మళ్ళీ యాడ్ చేస్తున్నాం. దట్ గివ్స్ ది ఫైనల్ ఫిక్స్డ్ ఎండ్ మూమెంట్. Any doubts in this slide?
No, sir.
Now I have the final diagram. So this is my final support reactions and support moments value diagram. So now this is my main consideration. Now RA 15.61, RB 84.39. So we can calculate what is shear force at various point and bending moment at various point. So shear force at point B, so that RB equal to 84.39. Shear force at point C, so that is minus 100 plus 84.39 minus 15.61. The same value valid up to point A. Now bending moment at various points. Bending moment at point B, so that is anti-clockwise minus 84. Bending moment at point C, so RB into 1.5 minus 84. So that is plus 42.16. Now bending moment at point A, just to reach that point A. So that is RB into 6 minus 100 into 4.5 minus 84.42. I don't consider the 28.07. So why? Because if we consider that value, we will get the 0. Finally, sum of the moments at A equal to 0. So bending moment at point A equal to minus A. So here the given value is plus and in the opposite direction that will be negative. At point A, SFT shear force value 84.39. At point C, minus 100 plus 84. So that is minus 15.61. The same value will be constant from point C to A. Next, bending moment at point B. If you see at point B, so that is anti-clockwise minus 84.02. If you take bending moment at point C, so while writing the bending moment, we will close that point with our hand. So if we close the point C, there is only one RB into 1.5 minus 84.42 and 100 into 0. కొంతమందికి డౌట్ వస్తుంది 100 ఉంది కదా సార్ అని. So that 100 into 0, why? Because we will take point C and the 100 kilonewtons is also on the point C. That is 42.16 plus. Now if you write bending moment at point A, just to reach that point A, So 84.39 into 6 minus 100 into 4.5 minus 84.42. I don't mention MA. If we can mention MA, that will satisfy the equilibrium equations. Our intention is either we can satisfy the equilibrium equation or not. At point A, there is 28. If we can balance the joint, if we can get the same value with opposite conversion, exactly our problem is right. If we can get some 30 or 40 values, we will cross check the numerical values. So in the next class, we will calculate, we will draw the SFT BMD diagram. Hello, Masindura. Hello.
Sir.
మీకు ఈ రోజు లాస్ట్ డేట్ ఇచ్చాను కదా ప్రాజెక్ట్ ఇది PPTs కి